Hi guys, in this video we will be discussing the geometrical meaning and significance of the derivative. Now with the derivative I actually mean dy by dx or the differential coefficient. Now suppose if there is a function f of x. I'm just going to assume f of x is x square. You know the illustration I used in the first video. The graph to x square is somewhat like this. It just comes here and then rises sharply. Now y equals x square. So upon differentiating this we will get 2x. Remember the power formula guys, nx to the power n minus 1. Now the white line represents x square and the yellow line represents 2x. 2x is actually the derivative to x square, so that's technically the whole geometrical meaning and significance of the derivative. Now you will notice that these two lines meet at a certain point right here. Now why is that? That's because the slope of these two lines at that particular point is exactly the same. What do I mean by the slope? Well, you see the green triangle over there? We're going to use that to find out what the slope is. The white angle that I have highlighted is actually the angle of the to that slope. Now slope is defined as tan theta, and this is our theta. So assuming there is some value of x at this one, let's say x1, and some value of x here at x2, similarly there will be at y1 and y2. Now slope is tan theta, and I told you that already, so that would make that y2 minus y1 upon x2 minus x1. So this is what I was talking about. Tan theta equals y2 minus y1 upon x2 minus x1. That equals change in y upon change in x, or average rate of change, if you remember from my previous videos. Now what you have to remember is that the values of x and y on both of these graphs are going to be different because of the functions that these lines are following. That is, the curved one is following y equals x square and the straight one is y equals 2x. But at this particular point the slope is 2. So now if you want to find the slope of one of these graphs, all you have to do is draw the graph to a differential, and then they will match up at some point. But you obviously don't have to draw it. All you need to do is just differentiate it, and then the numerical coefficient to x is going to be your slope. So that is pretty much the geometrical meaning of the derivative. Now coming on to significance. Well, significance is that you can like calculate the slopes to undefined graphs and find out value of one variable when the other variable's value is given. Now suppose this is a VT graph, that is for velocity time graph, and y1 is velocity 1 and y2 is velocity 2, with x1 and x2 also taking time 1 and time 2, and this represents non-uniform acceleration. So if you differentiate it, you are going to get instantaneous acceleration, because the time period in this is going to very small, tending to 0. That's all for today. Stay tuned for the next video. In the next video I am going to explain the chain rule in more detail, because that rule is very sketchy, plus it's very helpful in solving some of the questions.